So today's presentation will be the securing the Red Hat 8. It will be presented by Mr. Scott Knauss. Just a brief introduction of Scott. He was born and raised in Virginia. Scott joined the Navy right out of high school. In the Navy, he studied nuclear power, and later, after a skiing accident took him off the submarine duty, he started working with computers and networking. From there, he got out of the Navy and started contracting for the Navy. He worked first as an administrator, when moved up to working as a NOC engineer for the Navy's Mediterranean Fleet, and then as the lead engineer in that same NOC in Naples, Italy. Providing internet services and protecting the fleet from cyber attacks was a major part of Scott's career for more than 13 years. He then moved on to perform security auditing and penetration testing with the Navy's Red Team, validating new systems before they're released from to the fleet. He then left contracting for Red Hat, where he spent time as a technical account manager, cloud architect, and cloud success architect. Today, Scott is working for GDIT as the cybersecurity architect, helping to design and implement the new virtual data center for MPE with USARA AF in Wiesbaden, Germany. So without further ado, look, everybody give Scott a round of applause.
Okay, thanks, Captain Powell, for ruining my first two slides. That's all good. That's good.
Just one, please go, they're going to start serving food right now. If you need, the drinks are included for members, and you just need to go and order your drink up at the bar if you need a drink. Thanks, sir. Go ahead.
Yeah, food's important, right? This is a lunch and learn, right? Which means you need to have lunch as well as learn a little bit. So yeah, as I kind of hinted there, Captain Powell, thank you again for the introduction. That was my first two slides, but okay, it's all good. So yeah, we're going to talk a little bit about Red Hat today and securing Red Hat. First, I want to kind of gauge the room a little bit. Who is currently working with Linux on a regular basis? One. B, you count. That's two. Okay, I got two. All right, who thinks they might be working with Red Hat or Linux of some flavor in the near future? Okay, there's more. I got 4 or 5 now. And who's worked with it in the past? Okay, all right. So we've got some moderate experience and some folks that apparently have absolutely zero, right? Okay, so I'm going to try to speak to all levels today. For those of you on the WebEx, I'm sorry I can't poll you, but just hang in there. We're going to, like I said, we're going to try to cover all levels. I'm going to start out with a little bit of an intro into Linux itself, what it is. And give me just a sec. Let's see if I mute the speakers on my laptop, if that doesn't get rid of some of the echo. Yeah, that sounds a little better. All right, so still getting it. Yeah, it's okay. So if it's not bothering anybody else, I don't mind hearing myself talk. Anyone? Okay, good. So yeah, quick agenda. Introduction. Captain Powell already handled that. We're going to talk a little bit about the Linux, what it is. Then we're going to go straight into talking about Linux security basics. We're going to talk about SE Linux, which of course is security enhanced Linux. Anybody ever heard of that one? Yeah, a couple, right? Then I'm going to talk about SCAP and SCAP Workbench. These are some really great tools that have come a long way in the last 5 to 10 years. And if you're going to be securing a Linux box, these things are absolutely, they're a must-have. Let's see. So, yeah, Captain Powell already covered that. I lived in Italy for a long time, and then we moved from Italy up to here. So, yeah, and part of the time I worked with Red Hat, I was working in Italy too. So that was loads of fun as well. Actually, somebody asked me, we were talking earlier before we got started about when the last time we had an in-person event like this was. And, you know, I have to say, I mean, this is awesome to have all of us in the same room here. For those of you who could not make today, I'm really sorry you couldn't. This is great. But the last time I gave a talk in front of anybody, I realized was, I think, early in, or mid-17, when I gave an intro with the Italian Ministry of Finance for Red Hat. So it's been a little while. No, it couldn't have been 17. It would have been 18. But anyway. So a quick intro. Linux, right? What the heck is it? For those of you who have no experience with it, it started as a hobby with Linus Torvalds back in, what was that saying? 1991. What are we at? 2021 now? That's a couple of years, right? And in that time, he literally said when he put it out, he says, this is a hobby thing, right? He was trying to create a clone of the Unix kernels that were the big thing at the time, right? And he didn't want it to be this massive thing. He didn't want it to be what it has become initially, right? It was just a hobby. It started out with, the distribution started in like 93, and the first kernel, the 1.0 release, came out in 94 with 176,250 lines of code. That's it. That's like nothing, right? When you think about it, especially when you look a little further down the line here and realize that. So in 2003, Red Hat started their commercialization. That's when they started doing their subscriptions and their payment model and everything. And I stopped using it because I would have to pay for it. Then, and now here we are in 2021. And the 5.11 kernel, you can see here, 30.34 million lines of code, right? And who's doing all that, right? I mean, it's, 14% of that's just the core, right? That's the actual kernel itself. And most of the rest of it is drivers and little add-ons and stuff that have been added into it to do all sorts of whiz-bang things, right? But 15,600 developers. And they're not all from one company, right? It's the open source community. It's people sitting in their basement with nothing better to do but write some cool code. Yeah, he's looking at me like that. Okay. My office is in the attic, okay, but some people have it in the basement, wherever your office is, okay? Work with me.
Yeah, let's talk about the code portion.
It's a lot of code, right? But 1,400 companies, and that's all from a report that was done in 2017. Right, and that only accounts for code that has been written since they started using the Git management from 2005. And if you didn't know, Linus wrote Git to manage the kernel. That's where that originated. So that's Linux in kind of a brief history there. There's a lot more to it. Anybody who's ever heard Linus Torvalds talk or seen anything that he's written knows that he can be a very fiery individual. He can be kind of fun. And to clear up the debate, for those of you who are uncertain, Linux or Linux, right? Linus says Linux. So just go with it. Again, some more intro stuff here for Linux, right? If you look at statistics on Linux, who's using this stuff, right? Well, here you go. Doesn't look that impressive, right? January of 2021, 1.93% of all desktops are using Linux. That's nothing, right? February, 0.81% of global desktops, tablets, and console market. Again, nothing. And the net market share of Linux is only 2.35%. So why do we care? But wait. Okay, let's look at some other statistics. The 2021, 100% of the world's 500 supercomputers are running Linux. These are the big machines, the ones that are doing the massive compute things. Exactly, doing the big data computation. I'm trying to think of IBM's Watson, right? IBM's pseudo AI Watson, right, is running Linux. All of the supercomputers in other nations as well are all running Linux. There's one out in Tennessee that Red Hat helps manage that I cannot remember the name of right now. But what about something that we actually use, right? Because none of us are going to be using these supercomputers. These things are rooms full of PCs that are doing this stuff, right? The supercomputers. Top 25 websites on the world. Only 2 of them are not using Linux. Only 2. I don't know what those 2 are. Well, no, getting there. So 96.3% of the world's top 1 million servers on Linux. Okay, and 90% of all cloud infrastructure operates on Linux? I lost a tick there. There we go. So you think about cloud infrastructures, right? You think AWS and Google Cloud, right? These things where a lot of this stuff is moving to when you think about the cloud, Kubernetes, and containers and whatnot. Oh, wait, Azure. That's a Microsoft one, right? That's right. Azure is using Linux as well, right? Microsoft, right? Well, containers, most containers, if you're not familiar with containerization, they have to have a Linux kernel to run the containers because the vast majority of containers are Linux containers. So there has to be a Linux kernel for them to run those containers, right? Now you can do Windows containers, but you have to have a Windows server to do that, right? So containers is another topic, another day. But yeah, so even Microsoft is using Linux now. If you haven't been keeping up with the recent changes to Windows 10, you can actually run Linux with it. Right, it's the WSL, what do they call it? Windows Subsystem for Linux, right? Yeah, I have it running on a virtual machine that runs on my MacBook. Yeah, so just to check it out. Good stuff. Where am I? So what does that mean, right? So Linux is out there. It's all around us. The point here is to say that just because, as we looked at earlier, less than, almost half of the room has almost no experience whatsoever with Linux, but it's out there, right? So it's important for us as security professionals to think about this operating system that is running the vast majority of the internet, because if it's not secure, neither is the rest of the internet. So we'll go through some security basics here. I'm not going to go really deep into anything here as far as how to do individual configurations. I am going to do a quick demo of the SCAP tools so you can see just how easy it is. But I don't want to get too deep into anything today. For reference, though, if anybody wants to get deeper into some of this stuff, feel free to hit me up sometime. I've got copious amounts of documentation, and I can point you in the right directions for just about anything you want to work on. So system security, right? When you think about basic system security, the first thing that's going to come to most people's minds is configuration, right? Just like any other system, if you don't configure it to be secure, it's not going to be secure, right? Think about ports that you're listening on the network, password requirements, encryption algorithms that are being used. A lot of people think of FIPS, right? Anybody ever to deal with FIPS? Yeah, FIPS. That's a lot of fun, right? It's gotten a lot better on Linux. If you ever had to do a FIPS make a server FIPS compliant 5 years ago, you were in for a world of pain. Today, it's a flip a switch. You can install it from the get-go, Rel 8 with FIPS compliancy enabled, and you'll be better off. It does work a lot better if you install it with FIPS compliancy than if you try to add it on later, but you can do it. But a big part of security for any Linux system, regardless of the distribution, Red Hat, Ubuntu, whatever, is SE Linux. Now, SE Linux is security enhanced Linux, and originally it was an add-on to the kernel, right? Came out of NSA. Dan Walsh is the guy, if you ever hear his name. Yep. He was the guy that originated it and wrote the vast majority of the code and all of the utilities that come with Linux to do security to SE Linux. But really, as it says here, I'll just read it. It's a set of kernel modifications and user space tools that have been added to various Linux distributions. And it's it strives to separate enforcement of security from the decisions from the security policy and streamline the amount of software involved with security policy enforcement. Key concepts underlying SE Linux can be traced to several earlier projects within the United States with the National Security Agency, right? So the NSA was a big part of getting SE Linux set up, right? Now, what I want to do is I'm going to give you some ideas here, or I'm going to go through a couple of kind of like scenarios and give you an idea of what SE Linux can do and what its function is within a secure system in Linux. So let's imagine a system where we define types on objects like cats and dogs. Everybody with me? Think cats and dogs. And those cats and dogs, they're process types running on a machine, right? So any process that's running on a machine is going to be typed, right? And for our little scenario here, we're going to talk about cats and dogs. These are our two process types. Okay, so got our cats and dogs. Everybody with me on the cats and dogs, right? Two different process types. These are processes running on the system. All right, now, anybody who has a cat or a dog, you got to feed it, right? So we've got some objects on the system. Let's just say that they're files for now, right? Or a file system. Well, we have to type those as well. So we're going to type some cat chow, and we're going to type some dog chow, right? We've got our processes running, and they need to have access to their food, right? The dogs and the cats. Where's my next one? So we create some policies. And the policy rules look kind of like this, right? Really simple, right? Allow the cat to have the cat chow, and then he can eat it, right? So what we've got there is we've got the two different objects, the process, the cat, the file system, in this case, our cat chow, right? And then an action that he's doing on it. He's eating it, right? Now, in the real world, on the system, right, these are going to be like, a process that's running to do something. Maybe it's a daemon, maybe it's your mail server, right? And the things it's going to be accessing is going to be file systems, files on the system, temporary files that it has to access, right? And then the eat is going to be an action that it would take on those files. Think about actions that you can do with a file, right? You can read the file, you can write to the file, you can delete the file, right? Those are all parts of the policy that you build into for the SE Linux policy. Now, I'll back up a tick and say, you're not going to have to sit down and create policies for all this stuff, okay? Everything today, when you install it, it's also going to include policies to go with the into the SE Linux policy system that match up for that particular application. Mail server, the mail server is going to include SE Linux policies to make sure that all of the processes running for the mail server have the correct policies so that it can read, write, send, whatever it needs to do for the mail. All right. So once we have our policies all set up, then of course, the cat can eat the cat chow and the dog can eat the dog chow, right? All of our animals are happy. Yeah. How does that really do us any good? Well, there has to be some enforcement, right? Well, SE Linux is deny by default. So if you don't create a policy that says that you can do it, then you can't do it. So if the dog tries to eat the cat chow, the kernel is going to say no. It's not going to allow it. Likewise, if the cat tries to eat the dog chow, the kernel is going to say no way, you can't do that, right? And that's the whole. That's the in a nutshell what SE Linux is doing, right? All these policies are there. They're created for the individual applications, allowing them to do the things, only the things that we tell them to do. Only read from this part of the file system. Only write to this part of the file system. And obviously, from a security aspect, what we're trying to do there is if one of these processes goes rogue, or there's some type of insider event, or it gets hacked through a process running as a non-admin user that still has access to one of these processes, it's limited into how far it can go, right? So if I break into a mail server and I've got the access of the mail server, SE Linux is going to prevent you from doing anything that the mail server could not do. So you couldn't go take down the web server from the mail server because the mail server processes are not going to have the policy in place to be able to access that process running in memory, access the files that are in the scope for the web server itself, right? It's all about separation, right? Sorry, say again?
Putting up the defense walls.
Exactly. And I didn't mention it earlier, but by all means, if you've got a question, if something does not make sense, please raise your hand or just throw out a question. Shoot. Good question. So it's in the kernel. Yes. So the question is, on the file system, you have individual permissions for the files, and a user has permissions as the user to access the individual portions of the file. The difference is that that's in the file system portion, right? So those are file system permissions. They're part of the file systems, regardless of the type of file system, right? So Linux has dozens of different types of file systems that you can use. There's, ext3, XFS, yada, 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 right? But the kernel, what this does is it's in the kernel, right? And because everything has to pass through the kernel, it has a more granular effect on it, right? You can control it in a more granular way. You're right. You could say you can't access this file over here, and it would just give you a denied, right? But the kernel is going to enforce that in a stronger way, I guess, is the best way to say it.
Isn't it just making like another wall basically to go?
It is. It is. And there's also extended attributes that you can put onto the file systems as well, right? The access control lists and whatnot to go down in through the file system that are additions to the permissions on an individual file. Does that make sense? Yeah, I know. It sounds like they're doing the same thing, but you're also able to do it on a process level as well, right? So whereas the file system permissions are more generic, right? With SE Linux, you're talking about a whole group of things. You can object type them to where you're doing this whole group that can do it, and it's more dynamic as well, which we'll get to a little bit in the next section here.
So can I imagine it as like levels of permission basically? Like you have the level 0, which is the kernel processes, level 1, which is anything inside the kernel. Most of the times you'll find it categorized, say, in level 1 areas of, hey, these are all dogs. Where when you come through the level 0, it will say, oh, this is FIDA, this is Spot.
That's the next section, right? Okay. So yeah, the question is about the different levels of it, right? Yeah, and you're right. You can create different levels within the policies to be able to manage things differently, right? So, and in fact, that leads us right into the next section here, which is the MCS enforcement, right? So we can label our dogs and dog chow with random labels as well, right? And what that does is if you've got multiple dogs, they get a random label, right? So that you've got our dog with a random 1 and our dog with a random 2. And then we also apply that additional random numbered label to the objects that they need to access, right? Now, a good example for this would be containers, right? So you've got a container running that may be running three different containers running as mail servers, for instance, or a web server, right? But you don't want them to be able to access the files that each of them are doing, right? So as each container comes up, it gets a random number assigned to it that goes into the objects that it has access to, and also into the objects that it's running as, right? All of the processes for it. And the MCS rules, they say that, as long as the type enforcement is there, right? The original one that we talked about where we say this can talk to that, right? Or this can access that, right? As long as those type enforcement rules are okay, and the MCS label matches exactly, then it's going to allow it, right? So our dog random 1 can have his dog chow as long as it's typed with a random 1. But the type enforcement is still there too, so it's going to make sure that he still can't go eat the cat chow, right? And now there's some other elements of SE Linux that are available, but they're not as popular, so I didn't go into those today. So those are the two biggest things that are used, the most popular bits of SE Linux and how they function. I guess that makes sense. Do you okay now? Just keep going, yeah. Any other questions? Bueller? Okay. Anybody online have anything? I'm listening. Nope. Okay. So if you're wondering, those awesome drawings of the cats and dogs and that whole analogy, I didn't come up with that. That's actually from the SCAP coloring book. Not make that up. There is, in fact, an SE Linux coloring book. I presumably will get this presentation out to everybody afterwards. There's a link to it. You remember I mentioned Dan Walsh earlier, the guy that wrote most of the SE Linux code. Him and another guy did this, the SE Linux coloring book. It goes into some of the other aspects of SE Linux, the letter used ones too. So it really is. You can download the PDF and print it page for page and staple it together, and it works. It's yes, absolutely. Believe it or not, when I first started looking at SE Linux, that's what I looked at. That was one of the things I looked at that made me absolutely understand it and so much better than anything else that I read, which is, of course, why I tried to use it today too. So, yeah. Yeah, it's a coloring book. It's got dogs and cats in it. You can color them. It's fun stuff. All right. So this is a little bit weird too much. So for anybody that's already in the past worked with Linux, and you had to deal with firewalls on Linux, right? Because every machine is going to have its own individual firewall, right? Then you dealt with IPtables. Now, IPtables, yes? Okay, yeah. So IPtables is just there to create the rules that say, allow this protocol to connect to the machine from this IP address, or forward it off to this point. And you can do all sorts of crazy whiz-bang stuff with IPtables, including, changing the address, changing the port, mangling the packets themselves, blocking based on ICMP fields and whatnot too. You can get really into the weeds with it. So now, RHEL 8 was a breakpoint. They stopped using IPtables as the default. They're now using NFtables. Now, I put this in here because I don't want anybody else to do what I did when they start looking at RHEL 8 or something that's using NFtables. I think the latest Ubuntu is using NFtables as well, which is sit down and go, oh, I need to get the firewall to work right on this. I only want to be able to connect around. Let me do IPtables, permit this port to come in. Or wait a minute, let me look at the IPtable. What's there? There's no IPtables there, but I can't connect. Why is this working? And it's because it's an NFtable. So it's a different set of commands, and you have to look at it. And if you don't know that the NFtables are there and you just keep looking at IPtables, you're going to be really confused. Oh, man. I don't know. I really don't. Yeah, you just finished it, man. Come on. I'll look it up, though. I'll look it up because I really don't remember off the top of my head. I don't think I asked myself what the heck does NF stand for the first time, but I'll probably net firewall tables would be, if I can just make something up, that's what it stands for. Until I tell you differently, that's what it stands for, okay? There are some differences. Sorry? Yeah, well, I do it, but then it's great doing everything else. So there are some other differences in it and how it functions internally. Like I said, most of the big differences are under the hood inside the kernel, so you're not going to really see them. It does function more or less the same way, permitting things, network traffic, one direction or the other, forwarding it, whatnot. Yeah, you can perform multiple actions with one rule. That's a bonus. And then, yeah, so system firewall D, which is the daemon that was managing the IPtables, still works the same way. So if for some reason you worked with firewall D and firewall command, and you are familiar with that and creating firewalls, you can still use all those commands. They still work with NFtables. It just changes the back end and how it handles everything. And then if you find yourself in a position where you have this really great IPtables rule set that you were running on this machine that you've now upgraded and is using NFtables, IPtables translate will save your day. Just remember that. I didn't know that and spent an awful lot of time rewriting my firewall. Yeah, so we learn things, right? What else is there? Questions? I just kind of, again, just gloss over some of this stuff here. I only see one person calling us, so I'm not doing too bad. Yes, B. Yep. No, that is MLS, the multi-level, and it works in the way that you would expect, right? As you go up, they're tiered. So as you're trying to go back down, if it wasn't allowed at a higher level, it will get blocked, right? That's well, I didn't cover that one though, the MLS. But that is one of the alternative functions that doesn't get used as much with SE Linux. The question was about MLS, the multi-level security in SE Linux, and if it managed things in the proper order that you'd expect, and it does.
I'm suspecting it stands for net. This is part of
Net filter. Yes, that makes even more sense. Thank you. Net filter. See, I knew that. Thank you. All right, what's next here? So, SCAP. Anybody worked with SCAP before? RNF stuff, right? SCAP, right? Security Content Automation Protocol. SCAP works across the board. It's not just a Linux thing. SCAP is it's there in Windows stuff too, and it was designed to help us security types doing these audits and securing things to not pull our hair out for 6 months before an inspection, but only 2 weeks before an inspection, right? Because we're still going to be pulling our hair out before the inspection, of course. In fact, every time I think about SCAP, I think about the early 2000s working in the knock down there in Naples before our first inspection, and before SCAP existed, and before Ansible existed, and before all of these great automation tools that we have now, and all of the wonderful content that DISA produces for us in the form of STIGs and STIG baselines, right? Those things didn't exist then, right? I think I literally spent about 3 months before the inspection writing bash scripts to go through and secure the 20 some odd Linux machines that we had in the knock in the same way, right? I was trying to get to an automation, right? And but yeah, right. And if you've looked at some of the STIG content now, a lot of it will tell you, hey, this is the problem, or this is what you need to avoid. Run this command and look here to fix it, right? Then it just said, don't do this. This shouldn't be able to do that. And that was all you got, right? So it's like, okay, well, how do I do this? So it's research for a half an hour to figure out what this problem is. How do I fix it? Another half hour of research because nobody had done any of these things before. Yeah. Now you've got SCAP, you've got the STIG content, you've got the STIG baselines. So life is easy, right? As security folks. Everybody agree, right? And nobody is nodding. So RHEL uses the OpenSCAP, which of course has just been an open source version of the SCAP tools. There's a lot of tools that run a command line that go with SCAP to help you either remediate all of the problems on a system or find the problems on a system, and those are all based on those baselines that I was mentioning earlier that different organizations put out. Because DISA, for those of you who have never worked in the commercial sector, DISA is not the only one that produces this stuff. There's NIST, there's HIPAA, there's an Australian group that does it, right? That puts out this content for SCAP. So there's a lot of different standards that you can secure a box to. Some of them are really weak, HIPAA, and some of them are really stringent. If you've never worked with HIPAA, I'm sorry, you're not missing anything. I mean, it's like HIPAA is loads of fun because they say things like, you should encrypt your stuff. Anybody ever worked with HIPAA, really? Anyone? No, it really, I mean, originally that was all it would say, is that there was no guidelines whatsoever about what needed to be encrypted, what algorithms to use, how to encrypt it, where it needed to be encrypted. It just said data should be encrypted. That was the translation of it. It was like,
I think I might have one.
yeah, I had to get deep into HIPAA I was working with a nonprofit out of New York. It was all about medical stuff, right?
That's what
And
I was data processing with hospitals. It's a non-profit little clinic inside a high school. So that's where I was.
nice.
I was supposed to be data processing, but I was doing all the network.
Fun stuff, yeah. But yeah, so there's all these different standards that you can secure a box to. Hi, Dan.
Hello?
Dan raises his hand for all of the Linux questions.
Did I miss it?
No, not a one. You're good. So yeah, I did put all those in there, didn't I? So yeah, you're able to choose. So from the different standards and whatnot to either validate or remediate whatever standard you're going on, right? And there's a short list of some of the ones that are available, readily available. PCI DSS, by the way, is probably the most stringent one. That's the payment card industry, right? So the credit cards and whatnot, if you want to be able to process credit cards, you've got to get PCI DSS evaluation. Those are barrels of fun. All right. So, SCAP Workbench. Now here I'm going to see if I can make this work out. I'm going to do a quick demo here to show you guys just how crazy easy this is. This is going to be a little weird for me because I've got my back to the screen over there. Linux, right? This is a RHEL 8 virtual machine running on my laptop here. Hopefully everybody, yeah, it looks like it's showing up on the remote as well. So you guys should be able to see it as well. Now what I want to show you here is, this is just a terminal that's just open because it's Windows or Linux rather, right? So, but what I want to show you is this, oh, I can't see the cursor. Where did it go? Oh, I'll just type this, that'll work. The SCAP Workbench. So this is the tool that will save you so much time if you ever have to secure a Linux box. When I found this thing, I rejoiced because that whole 3-month time period of writing bash scripts goes out the window because all of that stuff is in this, right? So the first thing you're presented with is this little question here. So which content do you want? And the first thing you have to choose is just, you know, which version of RHEL you want. Well, let's go with RHEL 8 because that's what we're running with here. And we're going to load the content. And I know you guys can't read this because it's too far away, but it just gives you an idea of the interface and what's going on here, right? But you look at all of these here, and for those of you who are online, I'm sorry, I'm pointing to little bits and pieces on the screen here. Each one of these little things listed here expands out. And if you look at a STIG, because which one are we looking at here? Oh, this is the next thing you really want to do is choose your standard, right? And again, you can see there's this huge list of different standards here. We're going to come down and choose the DISA-STIG one because that's the one we all love and work with on a daily basis, right? And it lists out all of these things here. And you can see that each one of these, you know, pops open, and you can actually correlate this with the items in the STIG, right? And from this, you can go in and change some things, or add. Well, you're not going to add anything to it, but you can change different settings, right? So, like, there's a point where you have to set your password length, right? You can find the password length section in here. And if for some reason you guys want to have 52 character passwords instead of whatever the DISA standard is at the time, you can change it to 52. Don't recommend it. But you could do that, right? And it would set the enforcement for the password length. Just about anything else that you could change differently is you can set it in here. Now, big deal, right? Now, the big deal for this comes in these little boxes down here at the bottom. See the big one there that says scan, right? You can hit scan, and it's going to scan the box that it's running on, right then and right there, right? And compare how that system is configured with what you have set up in this interface here, right? And give you a report. And, you know, someone in the open source community. It's part of the SCAP project. It's part of OpenSCAP, right? So the OpenSCAP project created it, right? So, now I'm not going to run it. It takes about maybe 10, 15 minutes to run it. But it gives you a nice little HTML report in the end. B, you have a question? It comes with the distro profile. It's part of RHEL 8. It's in the, yep. If you install SCAP, you install SCAP Workbench from RHEL, from the Red Hat repositories, you get the DISA-STIG. Now what I did not do recently is validate how current this is, because I know the RHEL 8 STIG was updated within the last 2 months. I have not double checked to see how current it is. I expect that it's probably pretty current, Whatever's available to the rest of the world should be available and within the because they usually keep that stuff pretty well up to date. But I have not verified that. Right, so you can just scan this box here right away. Okay, Scott, that's great. That's a GUI tool, though. What about my server that's over there in the rack that I don't have a GUI on? You can't run SCAP Workbench if you don't have a GUI, right? True, but who's worked with Ansible? Anybody ever heard of Ansible? Of course, I told you Dan would raise his hand for everything, right? Ansible is an automation tool. It's been a champion for Red Hat for some time now. It was their own company. Red Hat bought them 5 years ago, I think. And they got rolled in as part of Red Hat. Pretty much everything that Red Hat is doing right now has Ansible in it. They use it for installations of all of their overly complex tools, OpenShift, OpenStack, Satellite, all of those tools are using Ansible for the automation pieces now. Ansible is designed for automation in large scale, right? So you write a playbook, is the way Ansible works, right? You write a playbook, it's just YAML. Everybody loves YAML, right? Anybody know what YAML is? Okay, Dan knows what YAML is, but he doesn't love it any more than I do. I know that. YAML is a syntax for configuration files. Most folks dislike it because it is very picky about spaces. Everything has to be lined up by spaces. Okay, but once you get over that, it's very powerful, right? Once you get into the groove of the YAML syntax and whatnot, so you write this playbook and it says, do all of these things to a particular system, and then you can say, okay, I want to do this on that system, that system, that system, and that system, or I want to do it on everything on the network. And you say, Ansible playbook, this awesome playbook that Dan wrote, go, and it does it. And it reaches out, it goes out, uses SSH to connect to the boxes, and then it runs the playbook, which can do configuration changes. So anything that you could do from the command line, it can do, right? So it's very powerful in regards to automation and being able to save you the time for doing multiple different things, or doing the same thing to a lot of different machines, right? Which of course is key in security, right? We want everything to be secure. We want them all to be done the same, right? Because if we know this one's secure and we do that one exactly the same, then it should be just as secure, right? Down here, this little drop down right here, I'm sure you can't read it because I can only barely read it. It says generate remediation role. And you can do that with either a bash script, an Ansible playbook, or a Puppet script. Don't use Puppet. Oops. Puppet away. Right? Anybody use Puppet? Puppet. No, Dan hasn't used Puppet. No, Puppet. No. Yeah. Puppet was another automation tool. Red Hat was using Puppet. They've tossed it out now, and pretty much everything is going to Ansible, as I said. Right. It is now, yes, but it's also available free in the open source community as well. Because I've got more experience with Ansible. Salt is very similar. Does it use YAML? Yeah, it does, right. So Salt uses YAML as configurations as well. And it actually functions very similarly to the way Ansible works. SSH out to the box, do all of these things. It's the primary difference with Salt and Ansible, and Dan, correct me if I'm wrong here. Salt, I think, requires a daemon running on your end nodes, right?
Yes.
Okay.
Uses a minion, and
right.
It uses literal MQ communication, so it's client to server. So the client initiates the contact to the server. Contacting them.
Right, and Ansible is the other way around, right? So where you're running your Ansible script from, it makes the SSH connection out to the box and then performs the actions that you give it. Now, there's a server side of Ansible called Tower that is just around the orchestration of running all these Ansible playbooks and whatnot. But that still functions in the same way. What else was I going to tell you about the differences there? Ansible also works on multiple platforms as well, right? So there are Ansible playbooks to manage Cisco devices, Windows devices, baseboards for motherboards, right? There's Ansible modules where, let's say you've got 100 servers that you need to configure the BIOS for. There's Ansible modules for some of those server types that can go out to all of the addresses on a network and look for that baseboard and make the configuration changes on the baseboard, right? So if you're doing like a massive server farm, that can be really helpful, right? Because logging into every one of those dang things and making changes in the BIOS, not fun. You know, if you're doing 5 or 6 machines, big deal. But if you're building a freaking 100 node compute cluster, it's a big deal to have something like that available, right? I don't think Salt does any of that.
Salt does Windows.
It does Windows. Okay. Yeah, you have to be able to load the minion, right? But yeah, so Ansible in that regard is far more flexible and just across the board does a little bit more than what Salt can do. Let's see, I'm getting close on my time here. Let's see, I think if I can manage to work things looking backwards here, I can maybe. No, let me do it this way because that's not good. I wanted to show you what do the reports look like, and I had it open, but apparently I closed it. Let's see. Here's the. So yeah, afterwards you get a nice, pretty little HTML report here that you can look at on the browser. Make that a little bit. You can read some of it, right? And it goes down and it breaks everything down for you, right? And this is after running the Ansible playbook on this particular box, right? And it took us down to only 3 highs and 22 mediums. And that was without me making any changes to anything at all, right? Just running the playbook on it. Now, darn, should have pulled up. FedEx, go away. Oh, I don't have it now. It's on. It's elsewhere. But yeah, so you can take that Ansible playbook now, and you can either run it from the box that you created the playbook on and point it at an individual server, or you could copy the playbook over to that server and run it on the server, either one, right? And it's going to go through and do all of the changes to make yourself, hopefully, state compliant, right? There's always going to be some things that it can't manage, right? At least not from a single run, particularly around file systems, right? So there are some state requirements, especially with Linux, that says, this particular file system needs to be on its own partition. Well, you really can't do that from a script running. You've got to do some reboots and shuffle some things around or install it correctly the first time. So it can't do those things. FIPS compliance requires a reboot to get FIPS compliance because that's part of the kernel. So it's not going to be able to handle that sort of thing. And there might be a few other pieces that it can't handle as well. But for the most part, using the playbooks from the SCAP workbench is going to save you, oh my God, so much time for configuring or securing a Linux box. All right, we'll leave the demo back. Come back over here. I think, yeah, that was the demo. So, yeah, in conclusion, I think I said this a little bit earlier, right? Linux is out there. It's all over the place in the network, whether you see it or not. No, it's not on your desktop. It should be. I'm just going to leave that there. But it's in the servers, it's in the server rooms, it's in the cloud, it's out there. It's unavoidable, right? People who say they've not used Linux, right? And I think there are a couple of people in here that said they've never used Linux before, right? You ever used Gmail? Gmail? Yeah, Gmail is Linux, every time you open a new window of Gmail, it spins up a Linux container somewhere in Google's cloud. You're using Linux, right? It's out there. And you know, as security professionals, that means we need to know the security implications of using it, and we need to be able to secure it when it's in our data centers. So that is all I had. Any other questions? Yeah. CentOS. So had to go there. So the question is, how about you, CentOS? Well, of course I have. No. So, and I'm glad you brought that up because it's something I had wanted to mention, right? So it depends on how you want to define binary compatible, right? So if you're just running applications, yes. For the most part, CentOS is binary compatible with RHEL. If you're talking about compliance, specifically FIPS compliance, okay? A CentOS box is not FIPS compliant just because the Red Hat version of the same version is FIPS compliant. Now, the reason for that falls into a lot of things. The biggest part of which is Red Hat spent the money to have the Red Hat version of it certified to the FIPS standards. No one has done that for CentOS. Okay. The other side of it is that when Red Hat builds, they build with a certain set of flags in their build infrastructure. That's their secret sauce. They do not share it. They do not share it with CentOS. They don't share it with Fedora. They don't share it with Rocky Linux, which, by the way, is will be taking over for CentOS when CentOS goes the way that it's going because of what they changed. Another story. So those other distributions, any of the derivative distributions of Red Hat are not actually FIPS compliant, right? Because while they may be the same source code exactly, that binary is not going to be exactly the same because of those compile time flags, right? So you can't say, oh, let's just use CentOS in the data center in a FIPS compliant requirement, or in a FIPS compliancy required environment, which, by the way, STIG is, okay? To get to the DISA STIGs, you do have to be FIPS compliant. If you want to be FIPS compliant and fully STIGged, you have to use Red Hat. I think there might be an Ubuntu that is under FIPS as well, but.
So you can check the common criteria evaluations on NIST,
Mm-hmm.
and they list all the OSs and which versions have had the E3, 4, or 5 standard certified. There is an Ubuntu LTS, whatever.
Yeah, 1804, I think.
But it's going to end up being 2-3 years old
before
they do another LTS, and then so you're running on an old.
Right, and Red Hat just got the FIPS compliance for 8.1, I think, right? And to Dan's point, it always lags because the current version of RHEL is 8.4, right? Now there's discussions in different places as to whether the follow-ons for a compliant version of RHEL is also compliant. There's some kind of wiggle room in there for it. If you're really interested in that sort of stuff, let me know. I just dug it up for somebody else a week or two ago, and I can pass that on. All the links and everything else for it. Thank you. That was a great question. Anybody else? More questions? Bueller? I see some people smile. Some people get that joke. I like that. Okay, I'm good. Captain Powell?
Oh,
Thank you.
yeah. Thank you, Mr. Knauss. It was a great presentation. We don't talk about Linux enough in the DoD, so that's great. So I know we haven't been in person for a long time. I'm Major Simon Sanchez. I'm the ISC Squared in Germany chapter president, and for the next month and a half-ish. So I'll be PCSing, and with that, not just because of that, but we will be doing elections that coincide with that, luckily. So we have a couple of positions that are available for everyone in the room and online. President, vice president, secretary, treasurer are all available, and we do need help. As we get back in person, I think that membership will pick up significantly, and we like doing these events where we bring people in and have talks and get to mingle at the tables and get to know everybody that's working in the IT community here in Wiesbaden and, you know, throughout Germany. So we really hope to grow and undertake a lot of big projects. We had a lot of stuff planned before all the COVID stuff kicked off, and that kind of tanked all of our plans. So we can pick those all back up here over the course of the next year, I think, and really grow the chapter and grow the CPE providing service that we provide, and the IT mentorship / education that we provide to the community. So we're really looking for some people that are eager to help out and contribute to the team. So if you are, reach out to either myself, Captain Powell, Mr. Vota, Mr. Blank. We can all provide you with information about the roles that you would be filling in any of those positions, and you know, what exactly help we need. We'll also have stuff on the website, and you'll see emails going out for all the members. We do have another event scheduled on the 9th. That will be, the presenter will be remote, but we'll still have an in-person component. We'll all sit here and get around together and watch the presentation here in Little Italy again. So thank you all for coming. Thank you again, Mr. Knauss, for presenting. It was a great time, and hope to see you guys all again